Good morning, folks. How you guys doing today? Happy Monday. All right. Hope you got your coffee. I'm just refilling mine here. So we've got project 1 today. We're going to go over the solution to that. I think most of you guys got it in, which is good. I might have had one straggler. And then we'll talk about loops. We're moving on to new stuff still. All right. There we go. There's the end of that pot. Awesome, awesome, awesome. A hat. Oh, I had a hat, Dusty. I have one. Let me see. Where did I put my hat? I already wore that one. Huh. Where did I leave my hat? Nope. Not there. I'll do this one. Here, this counts as a hat, right? That one, does that count, Dusty? Is that fair? All right. Let's be all tucked up in my hat here. Oops, we got project 1. We'll talk about the solution to that, and then we'll move on to loops, and then we can talk about our next project as well. Not exactly. I mean, it goes on your head. It just happens to be attached to the hood. All right. So let's take a peek here. Yeah, 25. 25's not everybody though, is it? Let me check. Let me see. Some classes have 27 and some have 25. And I don't. Or 24. I don't know. In person, we usually do 24 because we only have 24 computers in the lab. But we don't have a lab, so they put more students in, which is good. Right? It makes the courses a little bit bigger. Let's see. All right, so there's project 1. Oh, yeah, only 24 total, so that's good. So I think everyone turned it in. That is awesome, you guys. All right, so things we were going to do, right? Going to help our contractor friend build the fence. So we need their name, we need to know the post length, we need to know the total length and width. We're assuming that it's an even multiple of this post length. The length of the board that they're going to purchase, and then we need to figure out how many boards they need to build their fence. And then if you wanted a bonus point, you could find out the amount of board that was wasted here. So let's think through that again. I think we did a couple drawings already, but it's always good to think through your code. Let's see. Oh, you don't need the maze solver. Let me do a new. All right. So things that we need to do. Right, we need to ask for name and then store, we'll call it the answer. Right, so we'll ask them and then we'll store it. Right, we know what we're going to do is make a variable for it here, but we're just going through our steps. Right, so we get their name and we store it. And then we get the post distance, the length, and the width, and the board. So ask for post distance, length, width, and board length. And then store. Store those. Right, again, we're just kind of sketching on English here. So now that we have that, right, that's the easier part. The slightly trickier part here is the arithmetic. As we said, we're going to ask for some length distance of posts. So if my posts were, say, 3 feet apart, And my total length here then, right, say that was maybe 15 feet. So if my length was 15, right, 3 is 6, 3 is 9, 3 is 12, 3 is 15. Okay, and then maybe we had a length, say, of, excuse me, I don't know, how about 9? 3, 6, and 9. 3, 6, and 9. Right, and we know that would be a rectangle. So we're asking for these values. Right, and then we say, okay, well, what size board do you want to buy? So the size board that they're going to buy is going to make a lot of differences. Right, it's really going to change how many boards they need here. Right, so if my length here was 15 and my width was 9, right, we have lots of different options. So any length between 3 and anything bigger, right, is going to work, as long as, and we're assuming they're going to tell us good things here. We can assume that if their posts are going to be 3 feet apart, they're not going to buy boards shorter than 3 feet. Right, I think that's a relatively safe assumption for us. Otherwise, everything just gets screwy. So let's look at a couple different board lengths and see how that's going to affect the total number of boards. So board length here, and then total. So just for fun, let's shoot with some really big numbers here. So if the length is 15 and the width is 9, then the perimeter is 15 times 2 plus 9 times 2, right? So that's 30 plus 18 is 48 for the perimeter. So if they bought a 48-foot board, they would only need one board. Again, we're assuming like cuts are perfect and whatever. So, right, does that make sense? Because we know what the perimeter is. So anything more than 48 as well, they only need to buy one of those boards. I've never seen a 48-foot board at Home Depot before. But maybe you can get them at a specialty store. Who knows? Okay, if they buy something less than 48 feet, we're hopefully going to need more than we know we're going to need more than one board, right? But we can look at some different lengths. So maybe say, I don't know, let's look at, say, 20 feet. So what do we need to do to figure out how many pieces, how many distances between the posts they can fill with that 20 feet? Well, we're going to take 20. That's a 3. Right? We're going to take the board length, and we're going to divide it by the post distance. Right? So that's 20 divided by 3. Right? So that can fill the distance between, let's make sure I can do some math here, 6 posts. Right? With a little bit left over. So I'll have 18 feet that I'll cut into 3-foot sections, and I'll have 2 feet, single feet, right, of scrap. So I can fill 18 feet total between posts with one 20-foot board. So then I have 18, and my perimeter is 48. So, well, how many 18s then are in 48? Right? So I can take my 48, my perimeter, divided by the number of feet between posts. Does that sound fair? Right? Or we could divide that by 3 and then divide by number of boards. I think it's probably easier to go this way. So a perimeter divided by 18, because that's how many usable feet I can get per board. Now the problem here, when you do this arithmetic, I don't even know what number that is. It's somewhere between 2 and 3, right? Let's consult the calculator. 48 divided by 18, 2.666666. There we go. So 2.66 repeating. So how many boards am I going to have to buy? Well, more than 2, right? We're going to round up to 3. We're going to need 3 boards. right? What if I buy a 24-foot board? Well, let's take my board divided by 3. Board length divided by the post distance, right? So we just plug it into our formula. So we need to see what our formula is. So if we get a number with a decimal place, we need to round up. Because you can't buy 2/3 of a board. Right? So my perimeter is 48 divided by 24. Oh, I'm sorry. I'm jumping ahead. The board length divided by the post distance. So 24 divided by 3 is 8. And then my perimeter, 48, divided by that. Right? Oh, no, this is going to be divided by the number of usable feet. Or you could say 8 sections per board. No, that doesn't work. Divided by 24. That was the usable piece here. That's 2. So I only need to buy 2. Right, so we didn't have to do any rounding there. Right? Now what if we bought a 9-foot board? Right, so we're going to say, well, what's the board length divided by post distance? So 9 divided by 3, then even 3, so we can use all 9 feet. So then we're going to take our perimeter, 48, divided by the board length. The usable board length, right, usable board length is 9. And that's going to be, what, 5 point something? So we got to round up. So that's going to be 6 boards. Are you guys with me so far? So there's a couple things we're going to have to calculate, right? But the idea here is, what was our algorithm? We said I wanted to take the board length divided by post distance, right? That's that whole number, right? That rounded down. So we're going to get rid of any decimals here because we only need actual whole sections of posts here. Right, so whatever that number is, so that number, right, so we take that number rounded down, or the floor of that number, depending what kind of math term you want, or if you think back just to integer division, right, in Java, if you divide an integer by an integer, you lose all the decimal places. So we want int division here, right? That's great. So that tells us how many sections we're going to get, right? And that number then times the post distance is the usable board length. Okay? Now we could take the board length minus the usable board length, and that would tell us the scrap per board. Right? Remember, if we wanted to find out the amount of scrap here. So we have usable board length, right? We can figure out scrap per board, and then we take the perimeter divided by the usable board length. No, not the usable board length. What were we dividing perimeter by? Yeah, perimeter divided by the usable board length, right? Usable board length. And that one we have to round up. Now, rounding up here is tricky. There's a couple ways to go about it. If you guys Googled, you would have found there's a math function. If you didn't, that's okay. I didn't expect you guys to. I kind of thought people would use modulus. So to see if there's a remainder or a decimal, because integer division works here, it's okay. And we're not going to tell people to buy 2/3 of a board or 0.22222 board or anything here. So we could say, okay, so that number, that int division number is good. Division. We want that. And then we can check. We can say if the perimeter modulus, remember that percent sign, the usable board length? Board length. If that is there, then take the number of boards plus 1. That's if there's a remainder. So if there is a remainder, so if that number here, so how are we going to translate that? Well, what does if there's a remainder mean? It means if that number here is greater than 0. right? If you can evenly divide out your perimeter by your usable board length, you're going to have no waste, right? The remainder will be 0, right? Think back to 3rd grade. So when we did 48 divided by 9, well, there's 0 here, so then we drop it down, and then we get, right, so 48, so we get 5 is 45, subtract, we get 3, so 5, remainder 3. If there's a remainder here, if that's greater than 0, I need to add 1 board, right? I got to buy a board, I'm only going to use part of it. Right? So at this point, we're not going to have any scrap per board, right? When the 9-foot board can be evenly cut into our post, so there's no scrap there. We're only going to have one last little bit of scrap. Right? And that last little bit of scrap, right? So my scrap here is going to be whatever that remainder is, right? That's how much we need. So it's board length minus that remainder, right? Because I need 5 whole boards plus 3 more feet. So whatever I'm going to take the remainder away from that, right? My board length minus that remainder, I'm going to add to the scrap. You guys with me so far? So I haven't written any code yet. We're working through, these are the steps we're going to take, right? I think everyone understood that question on the quiz, the best way to get good code is to just write as much code as fast as possible without any planning. I think you all did great and understood that was silly. Right? Before you write code, we need to understand what we're trying to accomplish with our code. And I should turn off the lights here too. I could be like all dark mode here in my hood, like that. Maybe the camera just auto adjusts. So do we understand what we're trying to accomplish then? Right? We know what we're doing. We have our algorithm. We have all the things we're going to need. So now we can go write some code. And we're just going to turn it into code. Yeah, what was that show? Oh, someone told me it was actually really good and I should watch it. Mr. Computer? Yeah, iRobot, right? Or something? iRobot? Is that it? iRobot? What it was? Is that a show? No. It was like Mr. Robot or something. Yeah, Mr. Robot. Someone told me that show was actually decent. Got decent reviews on IMDb. Nice. The plot summary. Highly unstable young cybersecurity engineer and vigilante hacker. Complex game of global dominance. That sounds interesting. All right. So I'm going to make sure I put it in the right folder here. Right. 100. Project 1. It already exists. It is not empty. Did you already make one named Project 1? Huh. I wonder if... Nope, that's the wrong one. Nope, that's still the wrong one. That documents. Yes, 1500. What's in Project 1? Did I make this one? Yeah, there's a whole file with a bunch of stuff in it. On 127. Did we start a Project 1 and I'm just confused? Let's try it. Let's open it. Let's see what's in there. GitHub 1500 Winter Project 1. Wonder if I did the wrong Project 1 from a different class. Let's see. We'll see what it is. It's empty. Sure. Well, there we go. We got a Project 1. Okay, just cleaning this up here. Okay, so I think we're good to go. Right, we're going to take all the stuff we planned and we're going to write it. Now, some people will say it's a nice practice to put all your variables up at the top. And they're not wrong. Like, it is nice, and then it shows you've planned and thought out all your stuff. Like, hey, here's the list of variables I'm going to use for the project. So we could do that. Again, I'm not going to ask you guys to follow that particular format just for these kind of programs, but it's nice. Right? So we're going to have a string for name. We have an int for post distance, or distance between posts, right? Distance between posts. We're going to have an int for total length, an int for total width. Or is that fence length, fence width? I don't know. Sure. An int for board length. We said we're going to have an int for usable board length, right? We're going to have an int for total scrap board. Right, what else do we say? And then int number of boards to purchase. Right, is that all the things we had mentioned? Right, name, post distance length with board length. And then we calculated the number of board length divided by post distance with integer division, multiply that as usable board length. Okay, usable board length, good. Scrap. Ooh, we could have scrap per board, right? We could do that. Or total scrap. Yeah. Yeah, we can do that. So let's have a scrap per board. Int scrap per board, which might be 0. Scrap. Scrap per board, right? Total scrap board, number of boards to purchase. What else do we have in here? I think that was it. A remainder? We'll do that probably at the end. I don't know if we need a separate variable for that, because that's just a calculation. Sure, so we got a bunch of these. Okay, and then if we're going to be prompting the user for information, we're going to use a scanner. Keyboard equals new scanner given system.in. Right, so we can use scanner to get some information. That being says, oh, I don't know what this is. The little helpful light bulb says add the import. Yes, we want that. Or you just go type this in yourself. Right? I'm a fan of the tool doing it, but you're always welcome to just type this in yourself. Okay, so we've got that, and then we'll have name, right? Or we need to ask them. So, what's your name, friend? Contractor friend? Let's build a fence or something, right? And then we'll have name is keyboard.nextLine. Whoops. Keyboard.nextLine. I don't know what that search suggestion even was. We don't want that. We'll clean that up. Okay, we got name, and remember, and then it said we need to use their name in all further prompts. So hey, instead of friend, right, we'll say what their name is. So we'll say name plus how far apart are your posts going to be? And we'll have a post distance, or distance between posts. Distance between posts is equal to, and now you could use keyboard next int, and it would work okay because we're not doing other text, but again, I strongly encourage you to always use integer.parseInt. It's going to make this keyboard scanner thing work better in case we ever go between strings and integers or numbers. Or what happens is it leaves that new line character around, and the next time you ask for next line, all it gives you is a new line, which is really confusing. So I always like next lines. That's my preferred way. All right, so we got distance between posts, and then we're going to do pretty much the same thing for length and width. So what is the total length? And I'll have length, total length, and total width. Right. Is the total width. Right, well, I guess we could calculate perimeter too. Int total perimeter, or perimeter. That's probably close. Okay, so we could calculate that. So our perimeter is equal to the total length times 2 plus the total width times 2. "30-second delay." Is that what I've got? Some bad delay going on here, Biggie? Is Twitch having trouble again, or is it me? I think it's going okay. 2200 kbs. Oh, on your end, sorry. Yeah, sometimes it gets funny. I'm sorry. Cool, so we got perimeter. And then we need what size board they're going to use. Right, so what length board are you going to buy? And that's board length, right? Okay, so we've got all of our values here. Calculated all of them. We have distance between posts, we have total length, total width, we calculated the perimeter, we have board length. Yeah, we could do that after. I don't know. It's nothing wrong with doing it here, but if we do it after, then all of our calculations show up together, and it's nice. Okay. We got the perimeter, and now we need to start doing arithmetic. Right, we said we're going to take the board length divided by post distance as an integer times the post distance to give me the usable board length. And whatever the board length minus the usable distance was, the scrap per board. We'll have usable board length is equal to, right, we're going to assign it the value of this arithmetic. We're going to take board length divided by post distance, right? And that's integer division, so we know we're going to lose any decimal piece here, multiplied by distance between posts. So this looks really funny here, and I'm going to force this, we don't need it here, but I'm going to put some parentheses in just to make it clear, right? So what we're expecting, integer division, to truncate any decimal, right? Just so that you know we're expecting this to have happen. We know what's going to happen because these are integers. An int divided by an int is going to give you an int result, and that can't have any decimal places. Thank you, Java. Okay, and then we're going to have scrap length per board. Scrap per board is the usable board length minus, or no, I'm sorry, the board length minus the usable board length. And it might be 0, when it's okay. So in our total scrap, oh, we don't know how many boards we're using yet, so we can't figure out total scrap. So this might be 0. It might not be. Okay, we don't know what it's going to be yet. We'll have to figure it out. Okay, so we did that. We have usable board length. Now we're going to take our perimeter divided by the usable board length. Okay, so then total boards. Oops. Number of boards to purchase, there we go, is equal to my perimeter divided by the usable board length. Right, perimeter divided by usable board length, integer division, right? We know we want that. Integer division, expecting integer division again. So then we need to check. So now we need to do the remainder. So we're going to say if. Remember we talked about this last week. We'll say if the perimeter modulus the usable board length is greater than 0. So this is what we're comparing. Does this result, is it greater than 0? If it is, then take my number of boards to purchase, plus plus, or plus equals 1, right? Whichever way you would like to add. Have a plus equals 1. Okay, and if that was true, then I'm going to have some scrap. Yeah, King, it happens to the best of us, that integer division. So if we have a remainder, we know we have scrap. We're going to take board length. We're going to take our total scrap. There we go, total scrap board plus, right, add to it. Oops, I did a bad thing. That's all right. I should set these things. So total scrap. You don't always have to set values to them when you initialize them, but it's usually a good habit. That's unfortunate, because now I want to assign it a value. Okay, so I'm going to set total scrap board to 0. so that way I can add to it here. If you haven't set it yet, you can't add to it down here. So sure, set the value when declaring above, so you can add. Right, so total scrap then will be the board length minus the remainder. And again, I know this happens, but that's okay, right? I'm just putting it in parentheses to call out the order of operations. So if there is remainder, take the board length minus that remainder. Whatever is not in the remainder is scrap. Oh, here we go. Here we go. Okay. You know, we can fix this. We can fix this. Here we go. So once we know the number of boards to purchase as an integer to result, so I'll take our total scrap board is equal to the scrap per board times the number of boards to purchase. Because this number only works off of the whole number of boards here, and this is additional scrap. There we go. I like that. That's much cleaner. Okay, so total scrap, if there was scrap per board, the whole number of boards that we're using here, then if there's any remainder, is the remainder. Modulus. Okay. And then we can tell them how many boards to buy. You need name. You need to purchase number of boards to purchase. Plus boards. How's that look? Name plus. What's it unhappy about? Oh, and plus, not a comma. There we go. How's that look? Is that good? Did we talk about printfs? I'm trying to remember if we did that or not. Let's go look. Enter. I feel like we did. Sometimes I forget what's in what chapter. Yeah, printfs. There we go. So we can just do our formatting substitution. I like that. That'll be easier, right? Printf here, right? With a string here, %s for string, and a %d for digits. Right? Again, I don't know why it's digits, but sure. There we go. So name and number of boards to purchase. Look at that. Isn't that prettier? But then we also need our new line. Okay. So just substitute those things in. All right, give that a format. Let's try it. So I know what values I should expect to get, right? We did our table here. So let's try it. Let's see if I give it these values, do I get the result I'm expecting, right? Because any code that's worth writing is worth testing. Don't just hand me something without trying it. Okay, what's your name, contractor friend? Hey, I'm Eric, computer. If our posts are 3 feet apart, and our length was 15, and our width was 9, and we buy, what do we say? We had a couple different options here. We're going to try 48. You need to buy 1 boards. Oh, our grammar's not right, but that's okay. Cool, that looked good so far. Let's try it now with 20. Eric, how far are our posts going to be? 3 feet, 15 feet, 9 feet, 20 length, 20-foot board. We need 3 boards. Looking good so far. Let's try 24-foot boards. Oops, let's run it again. Eric, 3-foot posts. Total length is 15. Total width is 9. If we buy 24-foot boards, 2 boards. Perfect. It's not rounding up when it shouldn't be. Let's try it again. What do we say? A 9-foot board, right? Let's try that. Oops, Erie. I can't even spell my own name. Oof. Ooh, 15-foot posts. Okay, I'm just going to stop. That was probably wrong. Try that again. Eric, 3-foot posts, 15 by 9. And let's buy 9-foot boards. Right, we said 9-foot boards. We should need 6 if we did our math right. 6 boards. Okay, looking good so far. Right, how about... Oh, the amount of scrap. We forgot to tell them the amount of scrap for that extra point. system.out.print, well, just printf. You will have some digit amount of scrap board left over. Total amount of scrap. Right? So we didn't calculate the total scrap yet. Right? So if we had a 20-foot board, right, what was our total scrap for a 20-foot board? We could get 6 pieces with 2-foot scrap. So that would waste 4 feet, right, out of the 2. And then the third board we need, we only need to use 8 feet of it, right? Because 20, 40, we'd have 8 left over. So we should take the remainder of that would be 12. So 12 plus 4 should be 16 feet of scrap, right, with 20-foot boards. Let's try it. 3-foot posts, 15 by 9 with 20-foot boards. Oh, we forgot the new line. 12 feet of scrap. Is that what we said? No, I don't think we said that. 2 feet of scrap per board plus 12. Total scrap board. Board length minus the remainder. Huh. They did say 3 boards, right? That's good. 12 feet. I have 12 feet. So why didn't that work? Let's see. Let's try it one more time, make sure I'm not crazy. And then we're going to run it in debug mode. 3, 15 by 9, 20-foot board. All right, so something's not right. If I showed you guys debug mode, I think I have, right? You put a breakpoint over here at the line numbers. Debug mode is your friend. It will show us what's happening in our code, right? So instead of run, you run with debug mode. This is the best way to figure out why our program's not doing what we expect it to do. And coffee. Definitely coffee. Okay, so we got to come, this debugger console's not helping. We got to come back to project 1. So Eric's my name, 3-foot posts, 15 by 9, and 20-foot boards. So once it gets to that line, it's going to pause. So that's our output tab. We have this variables tab over here. This shows us all of the values that we've calculated. And this one I can't zoom, I'm sorry. But we see all these different things we've calculated here. So we have scrap per board is 2. Perfect, so scrap per board times number of boards to purchase is 2. Right, looking good so far. So then now we're going to use these step buttons. Total board length minus perimeter. Did I... Okay, I don't think we calculated a total board length ever. We could just multiply number of boards and then subtract from the perimeter. That makes sense. That's easy. I thought this would work, but let's try it. Let's see. So we're going to have our perimeters 48 divided by usable board length is 18. So we're good so far. So we're going to add 1 board to purchase. Now my total scrap board here, right, we're going to add the board length minus the division result. What's the remainder of 48 divided by 18? Boards times board length. Yeah, we could calculate total. Let's see. So what is 48 divided by 18? Okay, so 2/3, right? So the remainder there then. Huh. That's not what we need. No, because we only need the last piece. Yeah. So this math here was bad. This math here was bad. Right, do we have it in here? Oops, that's the wrong thing. So this math was no good. Right, because that remainder result then is off of the entire perimeter. That was the problem. So that's a bug. We had a bad logic in here. Right, so that remainder is going to be less than it should be because it's not just the last board. So I like that. I like that. So we don't even need scrap per board then, right? We can just calculate total scrap board. So we don't need scrap per board. We can get rid of that. And we'll just have a total scrap board then. I like it. We'll clean this up. So it's going to be after we figure out how many boards to purchase. Is the number of boards to purchase times the board length minus the perimeter. I like that. That's much cleaner. Tim to the rescue. All right, let's try that. So 3-foot posts, 15-foot distance, 9, total length, 20 foot, 12 feet of scrap left over. It still doesn't seem right. Am I expecting the wrong value here? With 20-foot boards, we use 18 feet. We have 2 per board left over. Oh, it's not a whole 20 there. No, something with our math is still wrong here. All this for a bonus point. Because the 2 boards that I'm cutting for the 3-foot sections, I can only get 18 usable feet out of each one. So I know I should have 4. And then that last board, the last board after that. So we've only used let's see. All right, let's figure this out. So if we take a 20-foot board here and we cut 18 feet off, right? We have 2 feet of scrap left over. So there's some scrap. We do it again, so we're gonna have 4 feet left over. That here is covered 18 twice is 36 total feet. Oh, no. Okay, so 12 is the correct number. 12 is the correct number. So we've used 18 feet of usable times 2. Gives us 36 feet so far. So our perimeter, 48 minus 36, means there's 12 feet left over that I need to cut off. If I take my last 20-foot board and I cut 12 feet off, I'm going to have 8 left over. So 8 plus the 4 is 12. So 12 is the right answer. $12 is the right answer. Okay, so that's good. It told us 12, and 12 was the right answer. It told me 12 previously, and I thought it was wrong. But I think this is better. Right? I think that'll work. Right? Okay. Yeah, I'm going to put parentheses in. Again, totally redundant. They're just nice to have. Happy with that now. Okay? Does that make sense for project 1? You know, this math was surprisingly not difficult, but tricky. Is tricky the right word? Because there's lots of different steps and sequences and a lot more that goes into it than just multiplication and division. Right? Not too much more, right? But whether or not we've got remainders, great, we have to add 1, we could do that sort of thing. Oh, if you did want the rounding up, so if you just Googled Java round up, you came up with math.ceil. is how you would round something up. Like, hey, math.ceil, round up. The problem here is that it doesn't work with integer division. So this nice little example here, right, is saying, hey, if it's an integer, it's not going to work. But if it's a double, it will work. So you either had to turn them into doubles, like cast them as doubles when we're doing our arithmetic, or just take them in as double arguments, and that could have worked for you. So if you use math.ceil, that's great. Right? To round up, that makes life even easier. So we could just do our calculation here and math.ceil it. Right, so this is, you used a double and a rounding function. We could take, this is the, let me just use a new variable here. It's easier calculation. Number of boards to purchase is math.ceil given, and then we have to treat it as a double. So you'd have to say double perimeter. Oops. Wow. Double perimeter divided by usable board length. And then this actually is going to be upset because math.ceil, sorry, parentheses are in the wrong spot here. This way. Okay. So now it gives me a different red line, lossy conversion from double to int. So math.ceil, for whatever reason, gives you back a double, which is silly because it's rounding to a whole number. So I've never really understood that, but sure. So if you turn it into a double first and then divide, right, you can round up with math.ceil. And you don't have to do any of this modulus stuff. Sure. Either way. Okay. So did anybody find math.ceil? Did you do some Googling for rounding up? Or did anyone go the modulus route? I encourage people to go to the modulus route just because it's a chance to use it, and we hadn't talked about, I don't think we talked about rounding up. So this one wasn't tricky, but I thought it'd be fun to use the modulus operator. Okay? All right, no one's super chatty, but that's okay. Remainder, modulus, operator. All right, awesome. So let me take my GitHub client here, and I'll commit this. Right, it says, oh, there's some changes to this file because they already existed. That's fine. So here's project 1. Complete. Commit and push. Right, and I'm going to go make sure it's out there. So let's go repository, view on GitHub. I don't need to submit it, but I think you guys figured that part out. But it's always good to make sure it got to where you expected it to get to. Okay, so here's project 1. In source, project1.java. Looks like it's all here. That looks happy. Right, and here's my URL. Okay. All right, before we start loops then, why don't we take a break just a couple minutes early. That way we don't have to interrupt the middle of the loop section here. I'll take that breakpoint off. You just click it again to turn off the breakpoint. Just click on, click off, click on, click off. I don't know if you can hear it, it's beeping, and it's a real tiny message. It says a breakpoint cannot be set at this location, down here in the bottom left. There's no command there, right? The funny thing is, like, breakpoints, they sometimes they'll move if you move lines the wrong way. I don't know, it looked like it was set at the wrong spot, but I guess it stayed. All right. Awesome. Why don't we come back, say, in about 10 minutes or so, and we'll pick up Chapter 4 loops. And we'll get started with loops, and then we will talk about the next project. Let's see. There it goes. All right. See you guys in a couple minutes. Alrighty, folks. How you guys doing? Think we're back? Alright. So we're going to talk about loops and the next project. So we've got a decent amount of time. I'll try not to run over too much here. Hydration, yes, get your coffee. Thank you. I didn't get a chance to start my other pot. I'll have to work on that in a minute. Alright, after class I'll make my next pot of coffee. So loops. Okay, so we start up a new project. Oops, not undo. Not undo. New project. This is chapter 4, loops. Does not want to put it in the right directory. There we go. Make sure I put it in the right spot so GitHub will see it. Excuse me. Alrighty. Close project 1. So, just an FYI as well, if project 1 did not go as well as you were hoping, and hopefully you could tell based on what the solution was, or my solution was, and how it went for you, I cannot recommend enough that you guys take advantage of some of these awesome opportunities through the ASC. Right? We have study group sessions Monday and Wednesday right after class. Those are great times for you to come, ask some extra questions, get together, talk with each other and our awesome supplemental instructor, and just help reinforce some of the things we've been talking about. The more you practice this stuff, the more you talk about it, the better it's going to get. But if it doesn't make a lot of sense, and you're still a little fuzzy on it, and you try and do these things, it's just going to make things worse. So not only do we have that, we also have individual tutoring you can go book. So come to that tutoring link in the syllabus, take a look at the Orchard Ridge schedule here, and you'll notice we have 2 amazing tutors. Tim might be familiar. Am I muted? No, I don't think I'm muted. I think I am. No, I'm coming through. Yeah, I can get the little echo loop going on here. But take a look. One of the tutors here might be familiar to you. Mondays, this is individual tutoring from 4 to 6, or with Miss Rika, who's also awesome. She'll tutor for 1500, 12 to 4 Monday and Thursday. So go ahead and talk with the ASC. You can give them a call, email them, and figure out what you want to do for individual tutoring. The longer you wait, if you're feeling behind, the worse it's going to get, because we don't get to forget any of this information, right? Everything we do is going to be building on things previous, right? So now that we know what decision structures are, we're going to be using decision structures everywhere else. If, else if, else if, else if, whatever. All those forever on out. We don't get to stop using them, just like math class. So if you're getting behind, you want to get caught up as fast as possible. And so take advantage of those opportunities. You can drop by my office hours. I'm happy to go over some things with you guys as well. Just let me know. Okay? Did you guys figure out the volume thing, sound thing? Okay. A couple of you did. Awesome. All right. So let's take a look. The loops here. So previously we had, I think we did that guessing game here. Let's take a look. Do we have a magic number? I think we did a guessing game. Yeah, where we'd guess a number here, and we would say if guess, right? Do this little guessing game. Well, this here was rather tedious, right? Because we just had to copy paste, copy paste, copy paste, copy paste. And that was silly, right? Essentially, anytime you have the same code in your program more than one time, you should feel bad about yourself. That's a pretty good rule of thumb when it comes to programming, because there's better ways to do it. But we just haven't learned the better way. So now we're going to talk about a better way to do it. So let's take our guessing game here, and we'll make it work even better here. So, sure, we can steal a bunch of this stuff. I'm going to go to raw mode because it'll copy paste a little better here. And we got that. Hey, Crow. Thanks for joining us. Nope. Why didn't it copy? Copy. No. Didn't I hit copy? Hit copy, right? You guys saw me hit copy. Control C, copy, 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 copy. Nope, 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 nope. Over here. Okay. It doesn't want to copy. That's really weird. All right, that copied. I was able to, like, copy this comment here. Let's try one more time. Copy. Paste. Okay. I don't know what I did. Don't know what I did. But here, we're just going to steal all this. And check this out. I'm going to give you a proper citation, even. Copy the URL. Copied from, boom. There's a citation. Now it's not plagiarism. Okay? Make sense? Okay, so a couple red lines, right? Java doesn't know what a random is. Okay, that's fine. Let's use the little light bulb. Add an import. Yes, use the java.util.random. Java doesn't know what a scanner is. Sure. Java.util.scanner. Let's add that import. Don't pick these other ones. Those create class options are terrible. Okay, you don't want those. Okay, so we got a random number. We'll guess a random number. In number of guesses. This. Now, instead of copy pasting this over and over and over and over and over, what we want to do is we want to continue doing this as long as something is true. That's the syntax that we get. Just like we have an if block that says, if this is not true, do something. Right? What we want to do is keep on doing something over and over and over as long as something is true. So we got a couple loops. So the nice common loop, the first one we're going to look at is called a while loop. We're going to say while something is true. And then you get a set of curly braces, and everything inside those curly braces is going to run while this thing is true. So what happens is when we get to the while loop, it checks just like an if block. It says, if this thing is true, you get to start what's in the curly braces. And it'll run from top to bottom. Everything inside the while loop will run. When we get to the end of it, it comes back up to the top and it says, hey, is this thing still true? If it's true, it runs it again. When you get to the bottom, it checks. Is it true? If it's still true, it runs it again. When you get to the bottom, it comes back and checks. Is it still true? If it's true, it runs it again. And again, and again, and again, over and over and over and over and over. So you gotta be careful here, because you can put anything in here. Right? So if we just put true, don't do this at home. Don't do while true at home. This will just never stop running, ever, because it is always true. There's no way to get out of this loop. And there's ways, we'll talk about them in a little bit, don't worry, but this will just run forever. So let's try it. Let's see what happens. Let's guess a number. How about 50? Too high. You know, it didn't build. Hang on. Properties. High on save. That's a stupid option. I just copied the first portion here. Just the first piece. Excuse me. Yeah, I didn't bother any of those other ones here. I just copied the top part. Okay, now let's try it again. There we go. It looks like it's doing the right thing now. Okay, guess a number. How about 50? Oh, too low, too low, too low, too low. Right? You see, it's just forever going to keep telling me too low, too low, too low, too low. Because there's the loop. When we get to the bottom, we come back up. Yes, true is still true. Got to the bottom. Yes, true is still true. So we're stuck forever. So a good rule of thumb is whatever's in here has to eventually be able to become false. So I want to keep on doing this as long as my guess does not equal the magic number. Right? If the guess does not equal the magic number, they didn't guess it right. I'm going to tell them too high, too low, and then what we can do, which is cool here, right? I'm going to cut that part out, and I'm going to put it down here. So inside the loop, if it's not the magic number, so like if they guessed it on their very first guess, I don't want to tell them too high or too low and keep them in here again. But if they didn't guess it right, then what I can do is tell them too high or too low, and then after ask them to guess again. Right, so what happens here, excuse me, let me clear this out. We have the magic number, and we guess, and then while wrong. So this part here is going to repeat, right? While it's wrong, we tell them too high or too low, or, right, one of those two, too high or too low, and then guess again. A, G, A. There we go, again. And it just keeps on going as long as they're wrong. As soon as they guessed it right, it's not wrong, and then we tell them, good job. Right? So this gives them infinite guesses. Right? And we're just going to keep on going over and 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 over. More hydration. Thank you. Man, I'm going to have to get some more coffee soon. Yep, that one's empty now. Man, do you guys miss going places? This mug just makes me really miss like going places out in the world. This is my happiest place on earth. And no, I don't get money if you guys go to Disney World. No. More hydration. Oh my goodness, I'm out of that one. Hang on, I'll get another one. We don't recommend the import star just because it's easier to be specific, especially with our tools. Right, our tools can just import specifically what they need. And I think that's usually the best way to go about it. So there's a fun thing you can do. You can say import.star, and star's like, give me everything in the utility package. It's a wild card here. There's nothing wrong with it, but I would rather just be explicit here, and just as we're learning. All right, here we go. TP'd a Baptist. Is that TP'd a Baptist? Or am I saying your name wrong? I don't know. Here we go. All right, so while this is true, we keep on going. So this is okay, right? Don't do while true at home. Yeah, I'm going to take the comment out because we got rid of it. So as long as guess is changing, there's a chance that this will eventually become false. So while we'll check the condition, and if it's true, it'll run. So it's kind of like an if block, but it repeats. So kind of like an if while, it's kind of like a repeating if block. Remember, when we get to the bottom, it just comes back up and checks this condition. If it's true, it runs again. If it's true, it runs again. As soon as it becomes false, it stops running. Or if it's false the very first time, it never runs. So there's no guarantee a while is going to run. No guarantee it will run. Okay? It might. If it's true, it does. So when you have a loop, you want to make sure that this condition has a chance of becoming false. Okay, so let's try it. Okay, guess a number. 50. Too low. 75. Too low. 87. Too high. So somewhere between 75 and 87. How about 81? That's too low. All right, so we're somewhere between 81 and 87. How about 84? 84 is too high. It's got to be 82 or 83. 82. We guessed it in 6 guesses. Look at that. We did it. Let's do it again. So if I just guess 1 over and over and over and over, right, the loop's going to let me do that. I can guess as many times as I want. Or I can, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16, right? On and on and on. That's silly, but you can. So 50 is too high, 25 is too low, 37 too low, 42 is too low, 47 is too high. So somewhere between 42 and 47. 45 is too low, so it's got to be 46. 49 guesses. Look at that. But it just lets us, it just keeps us inside the loop until we've guessed it correctly. Right? Sorry, I was looking for the Tylenol for one of the kids. All right. It's funny, we like in the same house, but we text each other all the time. Okay, so this while loop is just going to keep on going. That was our guessing game. Okay. Now let's make this a little bit more fun. Okay, let's make this a little bit more interesting. So let's ask the user how high of a number they want to guess. Do you want to guess? Right? You know, my kids, they get bored really easy with this guessing 1 to 100. And my son, who's 13, likes a bit more of a challenge. So he likes to guess between 1 and a million. Sure, why not? And it turns out, the higher you go, it doesn't actually take that many more guesses. Right? Because all you do is you split the difference in the middle every time. So it actually, think back to your math classes, it grows logarithmically. It's like a log curve, right? Every time you double, it only takes 1 extra guess. Every time you double, it takes 1 extra guess. So, you can go really high, and it's still only going to take so many guesses. Okay, so we'll ask them how high, and we'll have an int max number is an integer.parseInt of keyboard.nextLine. Yeah, with 20 guesses, you should be able to get something huge. Not quite. What do you think? So 2 to the 20? What's 2 to the 20? Or maybe 2 to the 19, right? Because you need one more. 2 to the 19. We should be able to guess a number up to 500,000, with 20 guesses. So again, not too bad. All right, so we have the max number. So now what I'm going to do, I'm going to use that instead of that. So I'll leave that comment, right? It's number not inclusive. So I'm going to add 1. So if they say a million, I'll get between 1 and a million. Because max would give me 0 and 9999999. So I'm just going to add 1. Guess a number between 1 and... we'll do a little formatted print here. Format. And %d for digits. And then also that new line, because that's terrible. Max number. Excuse me. We should probably tell them guess again, right? Too high, guess again. Too high, guess again. Sure. Let's try that. Okay, so we're just going to take a different value in just to change this up a little bit. Apparently the time model's not there. Okay, so how high of a number do you want to guess? Let's guess to a million. All right, so guess a number. So let's do 500,000. Split the difference. It's too low. All right, so 750,000. Still too low. So 87? 870,000? That was too high. Okay, so maybe like 82? 820,000? It's too low. Okay, so how about 84? 840,000? It's too low. Okay, so 80... let's just go 86. 860,000? Too low. Okay, so somewhere between 860,000 and 870,000. That only took a couple guesses, and now we're within 100,000. Okay, so split the difference. So 865. It's too low. Okay, we're getting closer. So 86. Let's go 8. Too low. Okay, so 869. Too low. Okay, good. So somewhere between 869,000 and 870,000. So 869,500. It's too high. Okay, so now we're within 500. So 869, 250. It's too low. All right, we're within 250. Those were just cutting in half, cutting in half, cutting in half, cutting in half. So 869, I don't know what, 370. Too low. All right, we're getting closer. 869, I'll just take it easy here. 400, too low. So 869, 450. It's too high. So now we're within 50. 869, 425. Too high. We're within 25. 869, 415. It's too high, right? 869, 410. Too high. We're getting there. 869, 405. It's too high. 869, 403. Still too high. Oh my goodness. 869, 401. Too low. All right, I think I know what it is. 869, 402. 21 guesses to get a number between 1 and 1,000,000. That's not too bad, right? Not too bad. Not too bad. Yeah. I mean, off by one's common in programming anyway. All right, so we have this while loop, and it just keeps on going until this becomes false. Right, this idiot. So go back and check the while condition. I can't spell condition. Excuse me. If it's true, run again. Okay? How's that feel? I know it's new, but does it kind of make sense what it's doing? I say, while this is true, keep on running. Like an if block that repeats. All right, so for fun, here, I'm going to put it in debug mode just to show you that it doesn't always have to run. So let's put it in debug mode and run it. Yeah, I think I showed you guys debug mode before because we cheated. This lets us cheat at our guessing game. All right, so again, you're going to go back to this one here. So we don't need that one. The debug menu. So let's just guess to 100. No, let's do 100 million because I'm going to be amazing here. So let's go to variables. Uh-oh. What's it waiting for? Oh, I have to guess the number first. Oh, shoot. Okay, so I did it in the wrong spot. I need the breakpoint up here. I can't stop it. I can't see my variables yet. What we can do, we can hit pause. There we go. So if I hit pause, now I should be able to see my variables. No? Doesn't show me? Oh my goodness. Can you... Okay. I'm just going to hit stop. Stop it. Let's try that again. Because I want to be able to see those variables. All right. 100, 100,000, 100 million. All right. The magic number here is 36,404,472. So let's guess a number. 36,000. No. Oh no, 36,404,472. So I entered it. Now we're going to step, right? So we're waiting. It's at line 23. All right, so we're going to continue. Now my number of guesses is going to go up by 1. All right, so now I've guessed 1 time. Now let's check. Is guess not equal to the magic number? Step. Look at it. My while loop never ran. Look at that. I guessed a number between 1 and 100 million in one guess. What are the odds of that? Well, 1 in 100 million, right? You know, your odds of guessing a number between 1 and 100 million are better than the odds of winning the lottery. Hitting the jackpot, don't you know? Right? Right. Look at Powerball here. Everyone likes to buy Powerball tickets when it's, you know, gets crazy high values and things. Powerball, the lottery is such a terrible system, by the way. It's just horrible. Let's see. Your odds of winning here. Prize and odds chart. Come on. Show me the odds chart. 1 in 292,201,338 is your odds of guessing the grand prize, the jackpot Powerball here. Oh, but your overall odds of winning are only 1 in 24.87. You might win something. It's such a terrible thing. It takes so much money from people. It's just a tax on people who can't afford it. Most of the people who play can't afford it. Right, which is it's terrible. I worked with someone who would buy 2 lottery tickets a day for like the daily, and it's just so sad. And someone finally told her, like, hey, you know, if you took those $2 every day and you put them into something else, you'd have a whole bunch of money. Like, oh, I would, wouldn't I? But yeah, the lottery is just a terrible thing. Terrible, terrible thing. Uh-oh, am I getting laggy, or is that just me? Let's see. Yeah, I think it's okay. Maybe a little bit of laggy. Yep. So your odds of guessing, right, 1 in 100 million are better than winning Powerball. Right? So don't waste your money. So, sure, some of our tax revenue goes to the schools, but that was just an excuse to take school money out of the general fund here in Michigan, right? It's a bunch of nonsense. And, I guess the argument is fair that if we don't offer it here in Michigan, people will just go to Ohio to play the lottery. But that's a terrible argument, right? I don't know. It just seems terrible. All right. So that's our while loop. There's other kinds of loops as well. So let's do another one here. So, okay, let's try more things here. Okay. Let's see if we can play rock, paper, or scissors. That's always fun, right? So let's have a computer throw. So we need to find out what the computer is going to do first. Right, so let's do a random number. So we'll say an int for computer. Choice is random.next int. Between 0 and 3, we'll give you 0, 1, and 2. Because I want rock, paper, or scissors. So I want to randomly pick rock, paper, or scissors. And then we'll have a string for computer throw. So if the computer choice is equal to 0, then computer throw is rock. Else if the computer's choice is 1, then the computer's throw is paper. Okay, and if it's not a 1, it's not a 2, else, or it's not a 0, it's not a 1, it's got to be computer throw is scissors. Okay, and we'll give that a little format. So now the computer picked one. So let's say rock, paper, scissors. Rock, paper, scissors, shoot. And we'll get the user's throw, string user throw. Right? Keyboard.next line. Here, let's play rock, paper, scissors. Scissors, sure. Okay, so that should play one time, and we need to check, right? Did we win, lose, or draw? So drawing is easy, right? So if the user throw, remember you got to use dot equals, and equal ignore case is even better, because I don't know if the user is going to type upper, lower case, whatever. The computer throw will tie. Right? If they equal, ignoring case, we tied. Else if. Now, this one is a little bit more complicated, right? We can do win, lose, and draw. We did draw, so draw is out. We're going to do win or lose. And I'd rather find the cases where we win, because I think that's more interesting. So if the user throw equals, ignoring case, rock, and the computer throw equals paper. Equals paper. So if I'm rock and the computer's paper, that's a win. Right? That's one win. All right, where's my parentheses? There we go. Or, remember you can use this logical or, so that's one win. Or, if I'm paper and the computer is rock. No, I'm sorry, rock, that's scissors. You guys got to catch me here. So if I'm rock and they're scissors, I win. If I'm paper and they're rock, I win. Or if I am scissors and they are paper, that's a win. So any one of those three, right? This and this, I'm rock and they're paper, they're scissors. Or I'm paper and they're rock. Or I'm scissors and they're paper. Those are wins. Right? If I didn't tie and I didn't win, you must have lost. right? Do I'm missing a parenthesis? Okay, or curly brace, sure. So let's try it. Guess a number between 1 and 1. It's got to be 1. All right, rock, paper, scissors, shoot. Which should we play? Should we rock? Should we be paper, or should we be scissors? I always like to play rock. Let's play rock. Oh, we win. Look at that. Oh, but I want to play again. All right. So let's do another. Let's put this all in a loop here then, right? If we want to be able to play again, let's do it. So we could do a while loop, right? And we could say, hey, do you want to play again at the end? And we could loop as long as we've said, yes, we want to play again. We could do that sort of thing. Or we could change it up. Uh-oh, am I losing you guys? No? Man. What is wrong with Comcast? All right, am I back? I like to blame Comcast. Nope. All right, sort of there. Sorry, folks. If it's any consolation, I'd lag just the same in Zoom. I don't know. I feel like lag in Zoom is terrible too. And then wah, 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 and then it's on wah, wah, wah. I don't know. That's fine. It's all good. I got nothing against Zoom. All right. I think we're back. So we did a while loop, right? We could say while. Well, what's going to be true here? Well, we could have a string like play again equals a y. We could say while play again equals ignore case y. We could do all of this. I just put all of that in a while loop here. And then give it a little format, right? Notice it's all going to get tabbed in. We could do that, sure. But then we need to ask them, right? You need to make sure that whatever's in here has a chance to change. So let's ask them. Say play again equals keyboard.next line. You want to play again? You want to play again. And I always prompt users like I'm expecting a yes or a no, like a Y or an N here. And that way they know what they're supposed to be typing. Right? Some users are, let's be honest, some users are dumb. I mean, I'm dumb too, so I mean, it's okay. We can make fun of our users too. Okay? So if they enter a yes or no, we'll store it. The while loop is done. We go back up to the top. It says, hey, does it equal ignoring case Y? Let's check. If they entered a Y, great, we're going to play again. Anything other than Y, we're done playing. Let's try it. Okay, rock, paper, scissors, shoot. Let's play rock. We lose. Yes, let's play again. Rock. We lose. Let's play again. Rock. We tied. Yes, play again. Rock. We tied. Yes, play again. Rock. Tied. Yes, play again. We haven't won yet. Rock. Now we win. All right, now I'm all done. Okay, we can do a while loop. Let me show you a different loop, though. So, like in this case here, we're starting the loop here. So we're the while loop with a known true value. Make sure it runs. Right? So I'm making sure it runs because I'm giving it a true value. Turns out there's another way to do it. There's a thing called a do loop. Now, do loops are fun because they will run at least once. Do loops run at least one time. So you will do this thing. Now, the reason I hate do loops, so now I'll have to say this is a string play again, is the way that you write them is really funny. So do, set of curly braces. At the end curly brace, you add a while. So it's a do while loop. I'll say play again. Again, dot equals ignore. Come on. Play again, dot equals ignore case. Y. And then you put a semicolon. This is the entire reason I hate do loops. There's a semicolon after the while. And I hate it. Drives me nuts. Play again. Can't find symbol. So it doesn't even know what a play again is. Remember, we talked a little bit briefly about scope, and we put something inside of an if block. You can't use it outside the if block. Same thing with loops, right? If we define it inside the curly braces, it doesn't exist outside the curly braces. So we still need to have a string for play it again here, but you don't have to assign it a value. We just declare it and get a value inside. So still a loop condition variable needs to be defined outside the loop, right? Because you have to say it exists outside the loop so you can get at it outside the curly braces. If we define it inside the curly braces, we're going to have no luck. And now you could also do a bad thing here, and this is going to cause all sorts of trouble. Thankfully, it warns us. It says it's already defined, right? Because you think, oh, I have to tell it it's a string. No. Once you've told Java it's a string, up above, you don't have to tell it it's a string again, right? So define it up above. So this loop will run at least one time. And then if they say they want to play again, if the while condition is true, it goes back up the top. Loops are terrible. Require a semicolon after the while clause, or the while condition. This is the entire reason I hate do loops. I'm going to try and never use them for this reason only. It upsets me because of this semicolon here. Because on a regular while loop, there's no semicolon. It's just like an if. There's no semicolon, right? It's just, sure. I had an instance back when I was taking this course years and years and years and years ago, where I had a while loop and I put a semicolon here. And Java's not going to freak out about it, right? That's legal here. What it means is the while loop does nothing. And now, thankfully, it warns us, NetBeans is smart enough, we didn't use NetBeans back then, that it's empty. It doesn't, none of these things to fix help. Those are all terrible suggestions here. Remember, you can have an if without curly braces. You can have a while without curly braces if it's a one-liner. I don't recommend it. Again, I always strongly recommend curly braces because it just makes things clear. Right, so if we wanted to, we could just say, we'll have an int number 0, and we could say, while number plus plus less than 100, semicolon. Well, we wanted to do one thing. That's right. One thing. Let's print number. We'll print number plus plus. We'll do it here. There we go. Well, number is less than 100, number plus plus. This is a legal while loop. Just always use curly braces. It's much better. Okay? This will work. Just like an if block, you're going to get the first line if you don't use curly braces. Boom. Eventually that loop will stop, thankfully. This is terrible though. Just always use the curly braces, because if you put another thing here, right, like number plus equals 10, try and like jump it by 10 every time, and you don't have curly braces, what's going to happen? It's going to run after the while loop is done. Only the first line without curly braces is attached. Right? It doesn't matter that it's tabbed in. Right? We don't care. And this helpful hint over here is, no, it doesn't matter. Confusing indentation. There we go. It's confusing indentation. Right? So this isn't part of the loop without curly braces. Okay? So just don't do that. Right? It's bad. Okay? But anyway, sorry. So you can have that semicolon there, because what that means is it's just attaching a single line. And remember, lines don't actually matter to Java. It's the semicolons. So the next command, we told Java, oh, that's the end of our command. Here's a semicolon. We're done. It works. And the funny thing, like, you can put curly braces around anything. I can put curly braces here and here. I've now added scope to random and scanner. But now I don't know what they are because I've declared them inside the scope. Oh my goodness, my computer's freaking out. We're almost done here. Almost done. Yep, so don't just add scope randomly. It's a bad idea. we got one last thing to do. Okay, let's talk about the next project, and then we'll come back to more loops next time. Project 2. Come on. Project 2. This will be due in 2 weeks, 22nd at 10 a.m. Right? So same as this time. And we need a new grade for project 2. Okay, this one's going to be worth 15 points. So we don't get to forget anything here. This will just be a text submission. Okay, I gotta save it and come back and do it so I can edit. I don't know what's wrong with D2L, but it's just obnoxious. There you go, and edit. Oh, did it totally error for you too? Oh no. Okay. I think it's back and mostly stable. Stable. All right, while I wait for people to refresh. Here, I got this one. This one's a freebie for you guys. I found this one the other day and thought you'd appreciate it. So, what does a janitor say when he jumped out of the closet? Supplies! All right. So, for project 2, we are going to build we need to configure our let's see, I'm glad you guys laugh at terrible jokes. It makes me happy. We're going to build a simulator for a lunar lander. Okay? So the idea is we need to send it controls. We have to send it commands to prepare it to land. Okay? So we're going to tell it what it has to do to try and get it ready to land. So remember, if it's tipped too far to the side, it's going to break a leg when it comes down. So you have to get it tipped the right direction and that sort of thing. Okay? So we're going to use a little bit of random here to make sure that it's going to work. So we're going to inside a loop, right? So inside a loop that runs until it has landed. We have to do a bunch of things. Okay? So inside a loop, it's going to happen over and over and over and over. The thing that will stop it is when it has landed. Right? So we're going to have this idea, right, that it can be like tipped. It can be tipped one direction, it can be tipped that direction, that sort of thing, all these different ways here. So we're going to have to track some things. So we're going to track distance from surface. Start at 10, that sort of thing. So inside the loop, distance from surface goes down by 1. Right, so it's going to get a little bit closer to the surface, a little bit closer to the surface, a little bit closer to the surface. Right, so landed means that distance to surface is 0. Right, it's going to keep on falling, but nice and slow. 1 by 1, 1, 1, 1, 1, 1, 1. Right, we're going to have so like there's the x-axis tilt and like the y-axis tilt, right, and z is just up and down, right? So have a value for x-axis tilt and y-axis tilt, right, as random values between -10, +10. Okay? So the tilt here could be some value of like -10 to +10 degrees tipped here. Okay? So commands we can give it, commands we can send are what change or x tilt. I don't know, what should we call it? Like our x-axis tilt, positive or negative. So you can come up with some good string. Like what are they going to type in to change the x tilt plus or minus, right? And you just change it by 1. This changes the value by +1 or -1. Okay. Same with the y-axis tilt. Positive or negative by 1. Well, we can thrusters. We can have a thrusters increase distance from surface by, we'll say by 2. And we're going to pretend we have unlimited fuel here. Unlimited fuel. So don't worry about it. Like we can do the thrusters as much as we want here. Okay? So we can change the x tilt, we can change the y tilt, we can thrusters, we can get a little farther away because we want to land here. So if distance, if we landed, and the x and y tilts are not 0, the lander breaks. Game over. Okay? Otherwise we win. So it has to land with 0 tilt on x and y, right? Positive or negative. Otherwise we win. Okay, so we got the thrusters. Okay? Then we're going to add one more command for fun. Just, again, this is silly here. This, activate self-destruct sequence. And then so with the self-destruct sequence, we have some special rules. If this is used, ask the user for the cancellation code. So make up some value. And don't let them enter other commands until they cancel. So we're going to have it as an option, but we're not actually going to let them do it. So if they enter that, we have to say, oh, enter the code to cancel. 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 And they just have to keep entering codes until it gets canceled. Does that make sense? So like, it's just a silly option here. And if the command entered doesn't match, give the user list of valid commands. Okay, so inside the loop, ask for a command, use the command, or give them the valid list of commands. So if they enter an invalid command, don't go down by 1. Right, only go down by 1 for valid commands. Right, so that way if they enter like ABC, and ABC doesn't mean anything, don't keep going down by 1, because then they're just going to crash. Right? Right, oh, sorry, I'm about out of time here, so I'll add a rubric in a little bit here. But the idea is all of this happens in a loop, and then all of that, this goes into another loop, asking if they want to play again. Play again. Right, just another play again loop. And then we'll regenerate random values for x and y tilt. We'll start back up at 10 feet away from the surface, and we'll see if we can land this thing with x and y. Not actually a tricky game or simulator at all. It's not very smart. Okay, we just need to get x and y to 0, and then land. Okay, I guess another valid command could just be do nothing. I don't know. Nothing. Nothing. Don't change any tilt. Because that way if we get our tilts correct, then, you know, we should be okay. All right. So that's our little lunar lander simulator we're going to try. And I'll work on that rubric where we're out of time now. So we post this one here. So again, we do have study group at noon. Definitely take advantage of that, especially if you are feeling behind, because it's just going to get worse, I promise you. Okay? So take advantage of that. Reach out for individual tutoring through the ASC. Drop in my office hours. Send me a message. We can hang out and chat on Discord, and I'll see what I can do to help. All right. I think we're all set. You guys take care. I'll give you one more dad joke on the way out. Let me find this one here. Where'd it go? I had one other good one that was a nice groaner. Oh, come on. Yep, okay. I don't remember if I told you to this one before or not, but that's okay. No, let's do this one here. So, at my restaurant, when I open a restaurant, because you know, that would be nice to do someday. It might be a lot of fun to retire out of this computer stuff and get into the restaurant business. I'm gonna have offer lots of different cuts of meat. You know, you can charge a lot for it. You can charge people a ridiculous amount of money to cook a steak for them. But I'm only going to have it in certain sizes. I'm going to sell it in 2 ounce, in 3 ounce, 5 ounce, 7 ounce, and 11 ounce portions. Because that one's the prime rib. All right. You guys take care. I'll see you around. I'm going to go grab some lunch. I'll be back for office hours about 1. Don't forget about study group. And you guys take care.